I'm back. So let's see. I've got it shared. You can see it, right? Hopefully. Now I'm all paranoid that Zoom's not working.
Yeah, it's working. I see it.
Okay, perfect. Okay, so let me go ahead and go through the lab first. So on this one, it's kind of a review. It's going to be on Newton's laws. So you're just going to be kind of looking at forces and really focusing on, hi, sorry, I have a little one with me today. You're going to be looking at Newton's second law. So let me open up Pivot. Oh, I don't know if I assigned them yet. I think I need to do that. Okay. But anyway, you're going to be looking at first this force in motion during a hockey puck, slap shot is what it's called. And you're just going to be using this idea of force equals mass times acceleration, finding your acceleration, and kind of just going through that. It's spelled out pretty nicely, so it shouldn't be too difficult to go through. And again, remember that my questions are going to be different than what's on Pivot, so just watch out for that. But that's pretty much it. We're going to do the same kind of thing where you have, you know, your measurements on here. You have your little ruler and a time, and you're just going to be taking measurements and creating a graph. And it says it all in here too. So let's see. Yeah, so see, it only has 2 questions here, but I put a few more questions in there so that it breaks it down a little better. Okay, and then the next section in that is going to be, let's see, this one with the rocket cart. And you're going to be, again, looking at Newton's second law, but we're going to be looking at the kinematics equation that I have here. And you're going to create some kind of hypothesis, and make sure that you always look at the hints that I write in, because I specifically put those in for a reason. I want to make sure that they're helpful, so I would always look at the hints that I give, and then kind of go through that. This one's a pretty short lab. I feel like I was kind of overloading you guys, so I kind of dialed back on the labs a bit. So it shouldn't be too difficult. Again, making measurements and time measurements. So that's all we're really doing here. Just more and more practice of that, of taking data and all of that good stuff. And then you're going to look at another graph here and kind of do, well, actually, yeah, I just have 1 question and they have 3. So I just have a few questions, or questions less, I guess I should say. And then there's also a conclusion, just writing a small summary of what you learned. So again, not too difficult. The lab this time is pretty straightforward, pretty simple. Okay, so I don't think I've assigned those, so I'll make sure to do that.
No, you haven't yet, because I've been checking and it doesn't have them.
My
it's
bad.
Just 1 and 3.
Okay, yeah, there's a lot of steps to these, so it's like to making sure everything is assigned and everything. I guess I could do that right now. Assign. Cool. Yeah, I forget to do that because there's so many other steps that I try to get on there. Okay, so there's activity 2. Let me get activity 1 assigned. And that should be there now. Cool. Let me make sure.
Yeah, they're in.
Perfect. All right, sweet. Okay, so that's with the lab. The lab's not too difficult. The homework, I think is gonna not be too difficult. So this time we're looking at uniform circular motion and gravitation for the homework. And you're going to need to look at the lecture, of course. Oh, let me pull it up. And when I go through the lecture, I know I kind of go fast, but I try to make sure to put all of the equations in there. So all the equations that are in the book should be in here that you'll need for the homework. So when you're going through that, just, I guess, pay attention to the equations. That's going to be a major portion in this. So for these ones, they should be pretty straightforward. Let's see which one might be a little bit tricky. Let's see. Well, that one seems pretty straightforward. I know there's a lot of words here in this number 4, but that one is actually like a 2-step thing. And I think that's it. A lot of these are very straightforward. They shouldn't be too difficult. There's only 9 questions. Of course, a couple of them have multiple parts, so that makes up for it. But yeah, this is really just learning how to use the equations, and it shouldn't take you guys too long to do it, go through it. I started on them yesterday, and it probably took me about maybe an hour or 2 to get through them. I don't know. I can't remember exactly. I'm almost done with it. One thing you need to be careful with, of course, is checking on units. This one in particular, I wanted to point out, number 7. That one is asking you to calculate the mass of Jupiter based on the data of, or for the orbit of one of its moons. And that's looking at table 6.2 in your textbook. So this is the table I'm talking about, table 6.2. And this is data for Kepler's laws. So what we'll do here, let me pull up another sheet. That way I can kind of get the ball rolling on this one, because once you figure it out, it's pretty simple. So I'm again looking for the mass of Jupiter. So I want to know, now my pen's not working, of course. It always happens. So my mass of Jupiter based on this data. So I have data where my parent object is Jupiter, and the satellite is a few of its moons. So you can use whichever data you want, either for Io, Europa, and so forth. It doesn't matter which. And what you're going to be using is this very last column here. Okay, so if I go up here, I have this relation, okay, and I have that also, I believe, in the PowerPoint slides, but it's here in the book as well. Okay, let me see if I can get it to work. Of course not. Okay, so I'll be using my finger when I draw things, so bear with me here. It's gonna look terrible. But this is the equation that I'm gonna wanna use because I want to determine the mass of some parent body where it has some kind of things orbiting around it. So I have my mass, okay, and I am looking for the mass of Jupiter, so I can put like a little J here if I want. I'm doing a lot of these. And I can use this equation yet again. So I'm gonna solve for my mass here. So I'll say 4, oh boy, 4 pi squared, oops, there we go, divided by G, okay, and then that will be times R cubed divided by T squared, Okay. And again, this last column is this factor here. Okay. So that's what I need from this table here in order to solve for my mass. Okay. Because my gravitational constant here, G, is known. That's given to us. Okay. So we just need to plug this guy in here. Now, the thing that might be a little bit tricky is the units, like I mentioned, and that's right here. So our units that are given to us are in kilometers, kilometers cubed over years squared. That's what the Y is, okay? And when we're looking at our gravitational force, G, I don't know where to find it on that. So I'm gonna go over here real quick. My units for G, so my G units is gonna be Newton meters squared divided by kilograms squared. Okay, so if you notice the difference between these two, this has a meters squared and this has a kilometers cubed. And then in my newtons, remember newtons is really just kilograms meters per second squared. Okay, so again, we have meters and then we have seconds versus years. So we just need to be really careful. We can't just say, oh, it just is magically kilograms. We have to make some conversions first. Those conversions are kind of stepwise. So you can either plug everything in, get some value, and then do your unit conversions, or do your unit conversions and then plug everything in. It's up to you. I'm going to go ahead and just focus on these units, and I'm going to convert them, okay? So I want this to be in something that is like meters cubed per second squared. So that's what I want to try to do. I want to try to get it to that, okay? If you already understand this, please stop me if I'm just kind of rambling. But this is, I feel like this was one of the most like, oh, wait a minute, hold on, kind of a steps.
I was skipping it just in case.
Okay, yeah. I feel like this is a little bit confusing. It seems simple, but then it kind of gets discombobbled. So first thing I can do is get my kilometers into meters. So I'm going to say, okay, in 1 kilometer, there's 1,000 meters. So I'll put that, 1,000 meters. And since it's volume or it's cubed, I'm just gonna go ahead and cube that. And so you're gonna have the same unit conversion in the middle here, and then you're just gonna cube the whole thing. So I can do the same thing with my years, but this one is gonna be a little more difficult because I don't know right offhand how many seconds are in a year, right? So I'm gonna go first say for 1 year, I have 365, 0.25 approximately days. And then in 1 day, I have 24 hours.
Oh, so you're gonna go from years to days to hours to minutes to seconds.
Yep, exactly. And
okay.
Yeah, and I can from, oh, whoops, that should say hours. Whoops. I know, what the heck? Okay, well, I'll do that again. I don't know what just happened. 24 hours. I know that in 1 hour, there are, like you said, the 60 minutes, and then in 1 minute, there's 60 seconds. So I can just say there's 3,600 seconds in 1 hour. because I just multiplied 60 times 60. So you can go straight from there, or this is the same thing as saying 1 hour, 60 minutes. Whoa. How did I do this without a pin? Okay, 60 minutes times 1 minute. I am so sorry for my handwriting. Wow, this is really terrible. Okay, 60 seconds. Okay, so this is the same thing that I'm doing here, just in one step, because I've done it so many times, and hopefully it kind of becomes second nature. Anyway, so now we have this conversion from years to seconds. And again, this is squared. So I will do the same thing and square this whole thing. So this is how I would convert. Let me kind of scroll out so you can see the whole thing. Convert the kilometers per years all the way to meters and then seconds. Okay, so that value that you get from here, from this column, oops, this fourth column here, you would just put that in front of all of this, and you can multiply all of this out and get some value, and go from there, plug in these things, and then you've got your mass. So it's not too difficult. One other thing to notice is that this ratio can be pulled from any one of its satellites. You can even notice that they're pretty similar, so it doesn't matter which one. And you can label it if you want to, it doesn't matter. You don't have to, because the numbers are all similar. So you can determine the mass, excuse me, by multiplying all of this out, putting one of these factors in front of that, plug in your G, and then you've got your mass. Okay. So again, this is the hardest part, I think. And for this next one, it's going to be similar. The ratio of mass to that of Earth. Yeah. So you'll first have to find the mass of Earth, unless it's already given to us earlier in here. I think it might somewhere. If not, you could always just calculate it real quick. It's not a huge deal, as you just saw. Plus, you already have this conversion here. If you do it separately like this, you already have some kind of conversion to make that. And then, let's see. So that's for 7 and 8. 6 is going to be using a similar equation, because you're wanting to find the acceleration due to gravity. And that is, let's see. Right, nope, wrong way. Oh, you know what? I erased it. I solved it right here in the lecture notes. So it should be earlier in this chapter, I believe. Different section. Yep, this one right here. So these aren't too bad. It's just practice, I think. Yeah, these, I don't know what else to go over, because I feel like a lot of these are pretty straightforward. And it's a lot of working with equations. And these equations, I feel like are easier in a sense than what we were doing with Newton's equations, because that you were having to like make your own equations, doing either F net in the X direction, F net in the Y direction. But here it's really just finding which equation and then plugging them in. So hopefully they're a little bit more straightforward this time. Yeah, I'm not sure what else to go over, because I feel like it's pretty straightforward this time. Hopefully. Of course, you can always email me if you get lost. don't know. Oops. Let's see. I have the progress quiz up and the discussion up. I have these lectures up. So I think we should all be good to go this week. It shouldn't be too difficult. Remember on the progress quiz, what was I going to say about the progress quiz? Oh, a lot of it is more conceptual. I think there's one or two of them that you'll have to do a little bit of calculation, but there's no time limit on them, so it should be okay. So hopefully this week will be a little bit of a break from test week last week. Hopefully a little less stressful. And I'll start grading the test later this week, I believe. Maybe tomorrow. Probably tomorrow I'll start grading them, but that doesn't mean I'll be done with them. Okay. All right, so again, let me know. You can stay on if you want and start doing the homework or the lab. And then if you come across a question, feel free to ask. Or if you're tired of listening to me, that's fine too.
I think I might understand everything for now.
Good, yeah, it's a lot of straightforward stuff. So I don't think it'll be too difficult going through this section here.
Like probably once this recitation's up on YouTube, I could probably just like rewatch it just in case if I get stuck, so I could
Yeah,
see if I could get through it.
yeah, I don't think I did put up last week's because it was like the test stuff, but I'll definitely put up this time. I've been recording this whole time, so it should be good.
Okay.
Yeah.
Yeah, I think we should be able to get through this pretty easily.
Yeah, I hope so. Hopefully it's easier than the last stuff. I know that the last stuff was a lot. First of all, you're just learning physics in the beginning, so it's kind of like, hey, here's a whole new thing. And then it's, oh, look at all this math. So I know it's throwing a lot of stuff at you guys.
Yeah.
All right. Well, thanks for coming. I appreciate it.
Yeah, I did come last time, but the thing was I had a doctor's appointment, so I was like, I can't really do it. So
Gotcha.
I was the one that popped in last week,
Oh,
but
that's
then I
fine.
left. So I had to
That's
leave like
okay.
the instant because the doctor called me up and I had to go.
Oh, okay. Yeah, that's fine. If you have to pop in and out, I know that all of our lives are kind of crazy right now, and we don't have like scheduled class time really, so it's fine if you have to pop in and out. It's no worries.
Okay, I think I can understand this.
All right.
I'll leave you be if you need me to.
Okay. No worries.
All right. Thank you for explaining the lab and the homework.
Yeah, no problem.